Hey, welcome back to Indices, Powers or Exponents Part 2. I hope you're happy with building up skills with this form of mathematics. Remember, the index or power form is just a neat way of writing repeated multiplication, and we're getting some interesting results coming out of it. Have a look at these 5 little expressions here, and what I want you to do is, can you see a couple of them? There's 2 out of 5 that have something new or different in them that we haven't discussed before. Can you see the 2 that have something new or something different in them? Have a look. Well, were you right? Here it is here. There's one, and this is the other one. And what's the difference? Hey, how can that be? How can we have a fraction or rational exponent or power, a ratio of 2 integers there, a fraction in the power? Hey, come on, what could that be? We've already had to handle the idea of a 0 power. We've already had to handle the idea of a negative power. What next? Well, you've just seen it. It's a fractional power. So let's see if we can work out what that might mean, whether it is possible to have a fraction as a power or exponent. So let's go down and have a look at some screen clipping here from Pearson's. And if we look at the screen clipping from Pearson's, just get rid of this here, then we see that they're investigating 3 to the half by 3 to the half. And according to the index or power laws there, when you multiply 2 numbers together, which are powers of the same base, you add the powers up. Okay, so let's do it. 3 to the half by 3 to the half, you would add the powers. A half plus a half is 3 to the 1, which is just 3. But hang on. Root 3 by root 3 is the root of 9, which is 3. The square root of the number is that thing which multiplied by itself gives the number back again. Hey, 3 to the half must be the same as root 3, because 3 to the half by 3 to the half gives 3 under our power or index laws. Oh boy, here we're on to something again now. We really do have to enlarge our original definition of exponent to cover some of these special cases that are arising now. Let's do another one. Let's come down here and just summarise that. First of all, a to the half would be the square root of a, and you can only find the square root of a number a if it's positive or 0. No, there, we'll go with that one then, and let's keep going and have a look. Well, let's do 5 to the 1/3 by 5 to 1/3 by 5 to 1/3. What will you do? You will add the powers. That's what we've just been practicing. That's one of the rules we established back when we were making conjectures at the beginning. So this is 5 to the 3/3. A third plus a third plus a third is 3/3. And that just means 5 to the 1. What number multiplied by itself 3 times gives 5? That's called the cube root. Isn't it? The cube root of the number is that value which multiplied by itself 3 times gives the number. So the cube root of 125 is 5. All right, so what does that mean? 5 to the 1/3 is a power way or an index way of writing the cube root of 5. Might be time to start looking at making a conjecture about any fractional power. Let's go down and have a look. So here's the first one. A to the 1/3 is the cube root of a. That number which multiplied by itself 3 times gives a. Okay, so let's come down and have a look at Pearson's summary of this now. A number raised to a fractional power 1 over n is the nth root. So 1 over 2 is the square root. 1 over 3 is the cube root. 1 over n would be the nth root. In other words, that number which multiplied by itself n times, if you like, gives the number, the nth root. We could have the fourth root of a number is that value which multiplied by itself 4 times gives the value. And then, of course, you could have a more general fraction here. Down here, a to the m on n. What would that mean? Well, it would be do the nth root first, do the bottom part of the power, that's the n part, and then raise it to the m. Do you want to check that? A power raised to a power. It's when you multiply the powers together. So yes, it does give you that combo power m on n. So a fraction like this means you have the root of the number, the nth root of a, and then you raise it to the n. So there's an interesting development here. We've got some very interesting new powers coming out of our work with developing our rules for this area of mathematics. We've really started something interesting. Come down, let's have a look at some examples here now from Pearson's, and you can check this in the textbook then. Here we have a to the half by a to the quarter. So that would mean the square root of a by the fourth root of a. But in this particular case, all we're interested in is simplifying it. So multiplication implies add the powers. Okay, so let's add them. A half plus a quarter. Do you remember how to add fractions? This is a problem. A half plus a quarter. I suppose you could do it on the calculator. Or you could say, what's a common denominator? They both go into 4. So if you change 2 to 4, you have to multiply by 2. So you have to multiply the top line by 2. And so we would get here, I just put multiply by 2 there, and I really don't want that multiplication in there. So we'll just put the result 2 there. And plus, this is already over 4, so plus 1 over 4, which is 3/4. Do you remember that process from junior maths? Or you want the quick method, not so good mathematically, you could cross multiply. 4 by 1 is 4, plus 2 by 1 is 2, over the product is 8. 6 over 8, which then cancels, 2's in the top, 2's in the bottom, cancels to 3/4. Bit of a longer way there, they'll cross multiplying, but it is a quick way of doing this process, the mathematical process down here. Okay, so we get a to the 3/4 as a result there. Let's come down a bit here, the rest of these. What about this? Change this to an index or power form. The square root of x to the 6. Well, there's x to the 6, and what does square root mean? It means the half power. We just established that. So it's x to the 6 all to the half. That would give you the same result. And then because you've got a power raised to a power, just remember that then, a power raised to a power, you multiply the powers together. So there's the first one, 6 times a half. Here it is down here. So it's x cubed. So lots of rules now to use to simplify bigger and bigger expressions in Powerland. Okay, coming down to C, what we've got, m cubed to the third times m to the third, m to the negative third, can't hardly see that there, over m to the third. So let's do the first one. Power raised to a power, you multiply the powers together. 3 times a third is 1. 3/3 are 1. So that's that result. And then we'll keep this the same, keep the bottom the same, and go to the next stage. So the next stage is to look at simplifying the top line. So you add the powers. Just watch that though. That's 1 plus neg a third. Okay, so that's going to come to 1 take a third, 1 is 3/3, take 1/3 is 2/3. So your next line is that top numerator simplified, it's m to the 2/3 divided by m to the 1/3. So gradually doing it, step by step. Now you've got division of powers, so remember, division of numbers, is subtraction of the powers. One of our rules. It's going to be the top power minus the bottom. There it is. 2/3 take 1/3. What's 2 dogs take 1 dog is 1 dog. So it's m to the 1/3. A lot of extraneous maths here, working with fractions, working with positive and negative numbers that you have to recall. Okay, let's go on. Another one, and let's look now, this time at using the calculator. So evaluate over here, just getting up the top here, find the value of 7,776 to the 1/5. The 1/5 power means the 5th root. So Pearson's over here suggesting what you need to do is you put in 5 and then go second function and pick out the root, and then put in what you find in the 5th root of. Let's do it over here on the Casio. So you need to go to run mode, and then the button that you're looking for is this down here. Can you see it in here? And I've enlarged it. That's what it looks like. That's the button. When you use the hat, that raises it to the power. 2 hat 3 equals 2 cubed. And then when you shift that button, you're finding the x root of the number. So what you need to do in finding the x root of the number is to first of all enter what root you want, the 5th root, and then the button or shift. You've got to go shift first, shift the root button, then put in the number. And that's what the display looks like. The 5th root of 7776, and then the answers displayed. So the idea here is to know that the fractional power of 1/5 can be thought of as the 5th root of this number, and it can all be done on the calculator. Okay, well, what about 289 to the half here? Going to this one. So what's the half power mean? It means the square root of 289. In this case, the square root is probably just come down here, and it's got a dedicated button here. X squared, and there's the root up the top of the x squared button. So it's shift the x squared button 289, and that's a little bit easier, that one. What about this one down here, 1331 to the 3rd? That means the 3rd power means the cube root. The cube root, then you would go into the button that we had before, this one here, cube root. So you would have to enter, as we've got over here, we don't have a cube root button on here. You'd have to enter 3 and then the root function, and then 1331 to actually get the answer there for the cube root, entering 4 into the x root of y, entering the 3, then the root button, and then the number. Okay, so the calculator can handle any root of any number, and so it's worthwhile being able to use that. Let's have a look at another comment down here. You could actually just use the fractional power. Don't change it to a root. Put the number in and then raise it. So this is TI here, the TI calculator. We're going to use this button. So you put 7776 and then use this to raise it to the power, and then you bracket the power 1 divided by 5, so that's raising it to the 5th. You must use a bracket, because what you're basically doing on the Casio is you're putting that and then the hat, and then making sure you raise it all to the 1/5. So if you leave out the bracket, it'll raise it to the 1 and then divide everything by 5. So you've got to tell the calculator 1 divided by 5 is the whole power, and the whole thing must be sitting up there in the power. So this is our button here. The hat is the way we raise a number to a power. All right, so you can play with that. Let's do some problems then. And working with fractional, or sometimes called rational indices, is a good word. Rational indices, because fractions, for example, 2/3 are ratios of integers, aren't they? Ratio now, ratios of integers. Ratios of integers. So this is an important mathematical term later on. Rather than call them fractions, we often refer to expressions that in a fractional way as ratios. Right, so these are rational indices, ratios of integers, of whole numbers. All right, so simplify each of the following. Here's a bunch here, just like the original first worked example, remembering your basic rules. So I'll just write them here, because in a minute I want you to pause the presentation and have a go. When we multiply two expressions together, which are powers of the same base, we add the powers. What's the difference here? Well, the powers are going to have fractions, so you've got to be able to add fractions. And then when we divide, we subtract the powers. So you have to subtract a fraction in the bottom line from the one in the top line. It's the top power minus the bottom. And then we have a power raised to a power. You multiply the powers together. So there's some of those as well. And of course, if you have two things times, all raised to a power in a bracket, you've got to raise each of those inside terms to that power. Or two things divided, raised to a power. You have to raise both of those terms that have been divided to a power. All right, so check your answers as you go. Make sure that you can actually do these rules now in fraction land, or with rational exponents, or rational indices, or rational powers. All those names are synonymous. An index is a power or an exponent. All right, so pause the presentation, check that out. You need to do all of those, I think. All right, moving on then, let's have a look at question 2. So in question 2 here, evaluating the following. This is a graphics display calculator practice. Graphics display calculator. So I wouldn't do all of them. Do maybe half of them. Do alternate parts, maybe A, C, E. Just make sure, etc. Just make sure you can get these answers on your calculator. Okay, so pause the presentation and have a go. Right, coming back, here's the next one. Use your calculator to assist you. Place these numbers in ascending order. Ascending means getting bigger. So we want smallest number, going up to ascending to largest number. That's what we want there. Okay, now just looking at them, you wouldn't have a clue as to how big each of those were, probably. Oh, you might. 4 to the neg 1. What about that one? Negative power or exponent means 1 over, so that's 1 over 4. That's about 0.25. But this one, you will use your graphics display calculator and then see if you can get them in order. And then all of these down here, probably most of them, you would use a calculator for. You might know some of the ones there. 3 to the 5th, you might be able to just multiply it out, 3 by 3 by 3 by 3, or use your calculator. So asking you to evaluate it and find the closest answer. All right, so pause presentation and have a go there. Mainly calculator business happening here now. Let's go on then and have a look at question 5. And probably this would be enough questions then, the first 5 here, to hone up your skills. There are more coming up and we'll have a look at those. But let's have a look now at simplifying each of these. So the idea is that they're getting harder, aren't they? don't forget a is a to the 1. Okay, so you probably combine these first. First of all, multiplying powers together to simplify that a to the 1/3 all to the 6, remembering a to a power and then to a further power, you multiply the powers together. And then you can go on and simplify the rest. Not a bad idea is to do the numerators first, that's the top line, simplify that and then subtract the power of the bottom line. So with something like this, remember you must do the power to everything in the bracket first and then go through and collect up your x powers and your y powers. The biggest difficulty here that's different from before is you're working with fractions. Okay, so a little care there is very, very important, and you must do the brackets first. All right, pause the presentation and just check out whether you're able to get these answers here. Okay, so moving on, let's go to the rest of the Pearson's examples here. And so they're more thinking examples as we go on. And you need to perhaps go back and think about the definitions of things like negative powers mean 1 over the usual positive power, that sort of thing, and being careful with that. And maybe just noticing that if we had, let's say, a 5 to the -1/3, that would mean 1 over 5 to the 3rd, or 1 over the cube root of 5. So you could do it that way on the calculator as well, or you could just take this and say 5, what, hat, bracket, -1 divided by 3. That'd be 5 raised to -1/3. So you don't necessarily have to go back and interpret it as a root, the 1/3 as a cube root. Okay, so have a go and check your answers as you go, because you don't want to perpetuate the same error. Okay, well, coming down then to some understanding problems, as Pearson's has set up each of their sections the same way. You have your basic fluency. Can you do it in the basic form, and then some harder ones here. So these are solving for x. So the most important thing here is to simplify as much as possible. So you have to do the bracket first, and you might try to get one term out of this. So x is x to the 1 by x to the 3 over 2. Maybe join those two together first and then do the squaring afterwards. Just remembering, when you've got an inside power raised to a power, then you multiply the powers together. Okay, see what you can do with those. That's getting a little bit harder to stick with it when you've got x's floating around as well there. So pause the presentation and have a go. Check your answers here. All right, just coming on to the reasoning ones here. So you'll have to think about these. X to the -2 is 1 over 4. So you might like to think now, if I have x to the -2, can I write this as a power? 1 over 4 is 1 over 2 squared. Is that a negative power? So think about that. So I think in this one, you're looking at trying to write these sides. We might divide that by that to get this one by itself. And then you might try to write the asterisk sides as a power of the same base on the other side. See if you can get a match-up so that you could solve for x. Writing both sides as a power of the same base isn't a bad idea here. All right, this is into heavier reasoning now, so pause the presentation and have a go. Well, we'll just finish off then with the last few and into the open-ended questions there. So question 11, pretty straightforward there to work through and try to toggle them around a little bit. I won't say much about that. Perhaps I will say when you have a fraction, you usually do the denominator first because that's the root, isn't it? So here it would be the cube root. So probably do that first, and you should be able to do that without a calculator, and then do the top power afterwards. In other words, you're thinking of the number as 64 to the third, all raised to the fourth. Okay, so give that some thought, heavier reasoning there. Here are our answers over here. The open-ended questions here, you have to think a little bit about that, and we've got some possible answers, sample answers here, because there's a few different ways of doing it. All right, quite challenging, those last few there. See what you think. You must get through, I think, first, 3 to 5 questions, so you're honing up all the rules. And then I think you should be happy if you can do that. Congratulations on getting through the powers and indices unit here. And I look forward to catching you in further presentations on other topics. But for now, it's cheers from me.